One of the applications of ellipses that we're going to look at is the idea of planets. I'm sure you guys remember from Earth science the idea that our orbits are not circular around the sun, but rather they are ellipses. And in particular, from Kepler's laws of planetary motion, we know that the sun actually acts as one of the foci of that ellipse. So if you think of two foci in the ellipse, and this is the orbit, one of these is the sun, and then at any given moment, Earth is out here orbiting the sun. The eccentricity of these different orbits, because each planet obviously has its own orbit, can help us look at some of the differences in the seasons that occur on different planets. Because depending on how elongated or how close to a circular orbit it is, that affects how much the distance from the sun changes. If we are given that the furthest Earth gets from the sun is 94.56 million miles, and that the eccentricity of our orbit is 0.017, we can calculate how close the Earth gets to the sun. So in other words, when the Earth is right here, and this foci is acting as the focus of the ellipse is the sun, this distance right here is 94.56 million miles. What we want to know is how close does the Earth get to the sun? Taking what we know about ellipses, let's now center this at 0, 0 graphically. And we know then that this distance, if we consider the orbit like this, is a distance of A. This is a distance of A. And then if we put the foci in, remember this is a distance of C. So since when it's furthest from the sun, it's 94.56 miles, we know that A plus C, this distance, is going to equal to that 94.56. But we also know a relationship between A and C for eccentricity. We know that the eccentricity 0.017 is equal to C over A. When we multiply by A, we get that C is 0.017A. We can then substitute that into this equation. We get A plus 0.017A is equal to 94.56. which leads us to 1.017A is equal to 94.56. And dividing both sides by that 1.017 gives us that A is approximately 92.98. Now that we have that 92.98 pictorially, that tells us then that what we can do is we can calculate C to be this 94.56 minus 92.8, which leads us to a C value, 92.98, excuse me, which gives us a C value of about 1.58. So the closest approach to the sun, we want to be able to calculate this value right here, which is A minus C. And so we can take that A value of 92.98 and subtract the 1.58 value of C to get 91.40 million miles. Notice the eccentricity tells us immediately that the orbit is very close to being circular, but this also confirms that this distance here, this 94.56, they aren't too far apart in terms of the furthest distance and the closest distance, indicating that the orbit is close to circular.